Hello and welcome to this MicroTasker Shorts video where I'll be showing you how to build a KBOOT compatible bootloader with AES256 encryption. This operates on either the UART or the USB-HID interface and can be built for almost any Kinetis part. Now I'm building in Visual Studio with a post-build GCC makefile step. The project, however, can also be built with KDS, MCUXpresso, IAR, Keil and various others. Now the first thing I'm going to do is to choose the board which I'd like to build for. I find this in config.h. Here I'm going to be building for the Freedom KL82Z board. Here you can see a list of other boards which are immediately supported. Since I want the bootloader on the serial interface, I ensure that serial interface is enabled, and also I choose the KBOOT loader mode and I enable the KBOOT secure loader option, which is unique to the MicroTasker project. I also wanted to be able to use this on the USB interface, so I enable the USB interface support, and I also enable the HID loader in KBOOT mode, and again I enable the secure loader mode. When I enable the secure loader mode, this also enables cryptography support in the library, and here I have several options. Now the KL82 chip has a TLC module, which is a low power trusted cryptography unit, and if I enable native AES256 support, and I don't disable this specifically, then the library will be using the LTC module for the encryption. If I don't want to use this, I can simply remove the native support and that will give me then software support. In some devices I can choose between the CAU or the mmCAU and the LTC. For example, the K82 has them both, and here I can choose which one I prefer. To be noted is that if both of them are not disabled, then the TLC module has priority. I'm going to be building with the GNU compiler, and you can see here that I have a target which I can select for the Kinetis with the GNU post-build step. What I need to check is that I have the right compiler settings. Here I confirm that I have the compiler set up for the Cortex M0 Plus core, which the KL82 has, and also I can check that I have the correct linker script file. Here we have KL12896. That is because this KL part has 128 kilobytes of flash and it has 96 kilobytes of RAM. It just remains now to build the project. Here we see that the build is completed and we have a code size of around about 15 to 16 kilobytes. In the serial boot directory I now have a file called microtaskerserialboot.bin, which I can simply load to my Freedom board. In a second Visual Studio window I have the MicroTasker project open, and now I'm going to make an application which we can then load via the secure loader. The procedure is almost identical. I again choose my target processor in the config.h of the application, and we then set up the project parameters which we'd like to test. In this case I'm going to be using a serial interface again, and I'm going to also be using the USB interface, which I'm going to be setting up to the USB CDC mode. I perform the same procedure in checking that my makefile is set up correctly for this chip. Again, the Cortex M0 Plus core, and then that we check that the linker scripts are correct. This is the linker script used for a standalone application, again the KL12896, and this one we have the KL12896BM, which is the bare minimum bootloader file linked to 8000, which is where the application will then be started by the serial loader. Again, once I'm happy with the setup, I simply do a rebuild. Before taking a look at the actual operation, there's one other point which is interesting to check, and that is the BAT file which we're using. Here we can see that the make file is being executed. You can also see that the microtask conversion utility is being called to take the binary file that was created and to do AES256 coding on it, using this as the encryption key and this as the initial vector. Obviously, when building this project yourself, you can choose any key and any vector. The key size is up to 32 bytes, that's 256 bits, and the initial vector is up to 16 bytes long. If the length of the strings or the binary used here is less than the required amount, they will be padded automatically by the microtask conversion routine. Now we can move to the output directory, where we can see the files which have just been generated. This file here is the file which is linked to start at 8000. I'm going to open this up in a hex editor. Here we can see that the start is very typical, in as much that we have the initial stack pointer value followed by the initial program counter value, and then the rest of the code where we will at some point see some strings. I'm now going to open the AES256 coded version of this. Now obviously the coded version will have no resemblance to the actual software we're loading because it's a very strong encryption. Now we can see it in operation. This is the Kinetis flash tool. I have the option to connect to my board via UART, which happens to be on COM30 because I have the Freedom board connected to it on this virtual COM port, or via the USB-HID mode. First of all, we're going to try the UART mode. So I connect to the board. Here we have the connection taking place, successful, and we have some information about the chip which has been found. Here then I point to the AES256 coded binary which we just created, and I do an upload. Note that we also have it set to 8000, that's the start address of our application. So we can see it takes a few seconds. The code size is around about 35 kilobytes, and we're transferring out 56 kilobaud. Here it's completed, and what I can do now is I can close this application, and I can then open up on Terraterm, in this case, connections to COM port 30 at 115 kilobaud and at COM port 27, which happens to be the application's CDC connection. And we can see here that we have the possibility to do various tests, and also I can do an AES256 test just to make sure that the algorithm is okay, AEC192 test, and I can also do SHA-256 testing. This is just an example of some of the things that the application which we loaded can do. I'm going to do a quit on that, and then we're going to see on the UART connection we have the same menu. We can do various things as well. I've just set the board back to the bootloader mode, and I'm going to start the KBOOT utility again, and this time I'm going to connect to it via the USB connection. The connection is also successful. We have the same file which we're going to be loading, so let's see what happens. Here we can see that it's certainly a bit faster, and again the application is up and running. Many thanks for watching this video. If your Kinetis based project requires a KBOOT compatible but highly secure loader with small footprint, you can find it in the MicroTasker project.